Hi there, my name is Ron Rogers, and I want to talk to you about American Eagle Flight 4184. This was a flight operated by Simmons Airlines, and it was October 31st of 1994. They encountered icing, and they ended up crashing. There were 64 passengers on board, 4 crew member, 2 pilots, 2 flight attendants. Of course, it's always tragic when you have a loss of human life, and as far as the crew, there was a flight attendant that it was their first day. Now, it doesn't matter if it's your first or you've been flying for 40 years, it's still tragic. But this one flight attendant, it was her first day of flying, and she was killed along with everybody else in this accident. But why do I make the comment of accidental test pilots? You assume, and they talk about that the aircrew were properly trained, rested, and certified to fly the aircraft. And of course, you assume that the aircraft is properly certified. Well, what happens when you're operating outside of the certification envelope? And this happened in this case. These guys, not beknownst to them, ended up operating well out of the icing certification envelope. And that's the whole gist of this story and why this is so significant. And I'll talk about the certification envelope for icing in just a second. Now, if you've been following my channel, you know that I've been involved with being a chairman of national committees and involved with testing, development of aircraft, and certification of aircraft, performance issues, and things like that. I was appointed by the FAA to be chairman of an electronics committee, avionics type of committee that set the certification standards for fly-by-wire aircraft. And we met for a little bit over a decade. And these operations, discussions, group committee meetings can become extremely heated in discussions. You have pilots, you have certification authorities from all over the world, and you have engineers and airplane manufacturers. They're trying to produce a cost-effective airplane. The pilots want an airplane that can fly in all standards. Now, there's some things that you can certify against and make a certification envelope. You can't build an aircraft that you could fly at high speed into a mountain. That exceeds the structural certification basis. Okay, that's pretty obvious. Well, let's talk about fly-by-wire. Now, there were a lot of issues on fly-by-wire because there are some pretty strong sources out there called emitters, high-powered radars. There's a deep space tracking transmitters that put out an intense beam out at Goldstone. And basically, the way we had to handle this was, okay, you've got certain things, you put them in restricted areas, and you don't go there. You can't build an aircraft that can be subject to that strong of an electromagnetic wave. I mean, we're talking, up in the military standards of trying to bring things down with electromagnetic weapons and things like that. So you really can't certify commercial aircraft against that. And even with the standards we developed, part of the time was the electromagnetic intensities inside the cockpit, the cabin, exceeded safe limits for humans. So these tests had to be conducted on aircraft with nobody inside the aircraft because it would be too dangerous. Well, it also comes for things like gust loads. Well, gust loads, that's turbulence. And most gust loads are covered, but not all gust loads, okay? There's some extreme gust loads that will essentially tear the wings off an airplane. Well, that may seem strange at first until you realize that, well, that's why we don't fly through thunderstorms, because the up and down draft in those things can tear an aircraft apart, as we know. So that's kind of putting the thunderstorm in a restricted area. That's why we have radar. That's why we fly around it. And so that's not in the certification basis because you just don't go there. Same thing is with lightning strikes or even electromagnetic discharges, electrostatic discharges that an aircraft will be subject to. There are intense lightning strikes, super strikes they're called. And I had a friend worked at Boeing, super engineer. He's passed away now, unfortunately. But we would talk about super strikes. There were just things you could not certify against. They were so intense, but they occur in very intense cells. Thunderstorms, things like that. So, okay, that's fine. You stay away from thunderstorms. Well, let's talk about icing certification, and I'll talk a little bit more in detail about this, but icing, anybody who's flown for a long time knows that icing can be very treacherous, unpredictable, and it varies a lot. I was involved both working for Cessna and in the Airline Pilots Association that on some icing certifications, and getting the water droplet size right, the temperatures, all the conditions can be extremely difficult. And when I've been flying as a commercial airline pilot, I have seen ice accrue inches in a matter of seconds. It didn't happen very often, but sometimes it would just be amazing to watch the ice accrue. And, that we need to get out of this. This isn't good. Aircraft have de-icing and anti-icing equipment, but that's not meant to allow you to set in the conditions for a long period of time. You need to get out of that. And in the military, a lot of the aircraft, well, the trainers, they weren't, all-weather Air Force was not certified to fly in icing. And we had a weather recall due to freezing rain, which was great because we ended up flying through it, a bunch of us, in the T-37s. And I remember coming in to land, we broke out of the weather. That's great. But we went through a rain shower, and all of a sudden, I lost all visibility. The canopy was iced over completely, front, sides, everything. So I ended up pulling the defrost knob out, had the flew the approach in, and had the student. I got a little hole, like that big of a hole, in the forward windscreen, and I had the student call out altitudes on the altimeter as I came in, kept the runway line. We came in and landed it, and then we opened the canopy so we could see, and we taxied off the runway. And I remember seeing the guy in front of me standing up with his plastic checklist holder, and he was trying to scrape the ice off so he could see where he was going. And that was something the aircraft wasn't certified for, and we typically as airliners don't fly in freezing rain. Well, we can fly in light freezing rain, but freezing rain we don't do, at least at my airline. But something that kind of brought this all to the upper fruition here, and let me talk about this, is I did a flight evaluation. Well, like I said, I'm not a very politically astute person. I'm more the engineering type, and this accident occurred on Halloween, October 31st, 1994. Well, Airbus brought over the ATR-72-500 in September 30th of 95. The full accident report of this accident didn't come out till July of 96. So we didn't know a lot at the time. Of course, there's always a little preliminary stuff comes out, but we didn't know the full details of what exactly happened in this accident. So I should have had a little clue as what's going on. This is the only flight evaluation that I've done where the president of ALPA came along on the flight, and some other high-ranking people. And we also had a reception at the French embassy. This was a big issue for Airbus, trying to establish or get a better reputation for this aircraft. So it was a little bit of a political issue here on this flight evaluation, and I wasn't fully cognizant that at the time. And I'll talk about this. I started to do a video on that flight evaluation and realized I better talk about this accident first, because there's a lot of tie-in to the accident. So let's talk about the accident. So they took off from Indianapolis. They're en route to Chicago O'Hare, and due to weather issues, they're were given holding instructions at the Lucid intersection, as you can see it depicted on the chart there. And they were told to enter the hold. And they entered the hold at roughly 10,000 feet, and they slowed to 175 knots in the hold. And the captain didn't like the deck angle and felt the aircraft was kind of wallowing, so he put down 15 degrees of flaps, which made kind of a better deck angle, and they entered the icing conditions. And of course, the aircraft gives them a warning that they're entering icing, and it adjusts the RPM and things like that. And they had the de-icing system was boots. Anybody familiar with little airplane knows about the boots that will inflate. I have them on my Cessna 310. They will inflate to break off the ice. You wait till you get a certain amount, and then you activate them, and they break off the ice. Well, they were in the holding pattern for rather extensive amount of time, and they were picking up ice. Nothing that they determined was too difficult, but the aircraft started to get roll excursions. There was a phenomenon due to an ice ridge that built up that caused him to have what's known as high moment aileron hinge reversals. This ridge caused this problem. And part of the problem was the ice was forming far aft of the boot's location to break it off. And they started to get roll excursions. They did, I think the first one 59 degrees to the right. The next one came along with about 120 degrees to the left. They had roll rates of 50 degrees per second, and part of the whole issue with this is they were getting very high forces. Of course, like all good autopilots, the autopilot tries to fight this for a while. They were hitting the maximum aileron deflection limits, which is 14 degrees, and they're hitting 13.43, I believe, was right up against 13.43, right up against the limits of the authority. And like all good autopilots, it handles it for a while and says, "Up, you got it. I don't like what's going on here now." And now it dumps them in their lap. And as you can imagine, 60 pounds of lateral force on that yoke, that is a lot of force. And it caused the guys a lot of problems controlling the aircraft. They were getting pitch excursions. The airspeed built rapidly. They got into a dive. They were rolling upside down. They hadn't had any upset training at the time, which may or may not have helped them in this situation. But they were, because the airplane was basically becoming out of control, and it was, 60 pounds of force on the ailerons can be very difficult, and they ended up basically falling out of the sky. And there was a point where it's speculated that they came out of the weather in a very nose-low pitch attitude, realized they had a problem, started pulling back, and part of the horizontal stabilizer failed, and outboard sections of both wings separated from the aircraft, and of course it crashed into the ground. So here's where the accidental test pilot situation comes into play. The FAA Flight Certification Appendix C gave water droplet size for icing conditions that range from 15 microns to 50 microns. The maximum continuous you could be in was 15 to 40 microns, and then max intermittent went up to 50 microns. While freezing drizzle was 200 to 500 microns. That's outside of the certification envelope. And then, of course, freezing rain is 1,000 microns, and that could actually go up with supercooled droplets up to about 2,000 microns. So, like I said, icing conditions can be very difficult, very hard to predict, and extremely dangerous. And these guys were operating outside of the certification environment of the aircraft. Now, they had ice protection of the boots on the horizontal stabilizers on the wings and stuff like that. They had detection. They had ice probes. They had heated propellers, heated pitot tubes, things like that. But part of the issue with this is the fact that the ailerons were manually controlled. Now, anybody who's flown a Cessna 172 knows that what a reversible flight control system is. You have a direct mechanical linkage. You can move the yoke and the ailerons move. You can move the ailerons and the yoke moves. Okay, so what happens is forces get fed back. As you fly faster in a 172, the aileron forces become higher because you're deflecting into more of a slipstream of air. The forces on the controls are reversed. That's a reversible flight control system. When you go to hydraulic flight control systems, they're an irreversible system, and they have to put in various sorts of artificial feel. So when you go faster, you can they adjust the fuel, computers, springs, bob weights, all sorts of stuff. So you feel heavier forces, and it kind of tells you that don't be real aggressive on the ailerons at high speed. It can give you a problem. But in a reversible flight control system, you don't have that situation. What was happening with these high hinge moments was the forces on the ailerons produced by the icing event were being directed back into the yoke. Now, they also had spoilers there, but the main issue occurred with the ailerons. And here's a bit of the aileron. You can see the depiction there. They're quite lengthy, and the forces on the ailerons, of course, made it very difficult for the pilots to counteract that. Now, probable cause. The NTSB came out and said the probable cause for this accident was a loss of control attributed to sudden and unexpected aileron hinge moment reversal that occurred after a ridge of ice accreted beyond the de-icing boots because ATR failed to completely disclose to operators and incorporate in the ATR-72 airplane flight manual, flight crew operating manual, and flight crew training programs adequate information concerning previously known effects of freezing precipitation on the stability and control characteristics. So ATR knew about this. Airbus essentially knew about this, and they didn't properly relay it to the operators. And they also chided the French Director General for Civil Aviation, the DGAC, inadequate oversight of the ATR-42 and 72 and its failure to take necessary corrective action to ensure continued airworthiness in icing conditions, and also a failure to provide the FAA with timely airworthiness information developed from previous incidents in icing conditions. And the bilateral agreements say that, hey, you're supposed to do this. And contributing to the accident was the FAA's failure to ensure that aircraft icing certification requirements, operational requirements for flight and icing conditions, and FAA published aircraft icing information adequately accounted for the hazards that can result for flight in freezing rain and other icing conditions not specified in Part 14 Code of Federal Regulations. That's the big Bible of federal regulations. Part 25, which these are certified under Part 25, being air carrier, Appendix C, and just they didn't the FAA didn't provide adequate oversight. Well, of course, my dealing with Airbus and the French people is basically they are extremely sensitive. If you question anything about the design of their aircraft, they will come. I mean, it's almost like you're spitting on the French flag. They take it very personally, and they don't take it very well. They consider it not a technical discussion, but to them, in my experience, has been, I don't want to tick off any French people here, but my experience has been they consider it more of an insult than a needed technical discussion. Well, of course, the DGAC, they went and they did their own investigation, and they attribute it to aileron deflection leading to loss of control. But they were trying to basically say it was pilot error. Okay, that's the fallback. If you don't like what's going on, it's the darn pilots that are responsible for this whole thing. It's their fault, and basically that didn't get a lot of traction. Now, in 1996, the FAA issued 18 airworthiness directives affecting 29 turboprop aircraft, having a combination of unpowered flight controls, pneumatic de-icing boots, and in NACA 5-digit sharp stall airfoils, as they called them. And they wanted to make revisions for higher minimum speeds, manual control, and different upset recovery procedures, as well as physical changes to cover the area of the de-icing boots. Basically, they wanted to extend the boots farther back. The ATR 42 and 72 aircraft are now compliant with the icing requirements imposed by these 18 ADs, but the de-icing boots only still went back to 12.5% of the cord. And prior to the accident, they only went back to roughly 5 and 7% of the cord. But they found out that ice could form as much as 23% back on the cord, on the tail, and 30%, 23% on the wing and 30% on the tail. And both of these were beyond the reach of even these extended boots. So what basically happened was everybody who was operating this aircraft took and kind of moved them south. And of course, they did a very extensive accident investigation. And as kind of a little side note here, the family later came to the site and they found some human remains that had not been picked up. But the trouble with an accident like a high speed like this, it can be a big mess, and they don't always do the best cleanup. Now, a little bit about icing certification. Of course, after this accident, they went back. They got a Air Force tanker, and instead of spraying fuel on the aircraft, which would not have been productive, to do the icing test, they have a little spray bar assembly. And this is what it looks like. And of course, you got a KC-135 you can set there. But the whole issue on this is you've got droplet size situations. You got temperature conditions. And we had at Cessna, for doing our icing tests, we had a modified Titan 404 that we had a spray boom on it. And we actually had a little thing that came up by the tail. And you could spray water and collect ice on the leading edge surfaces of the aircraft. They also had, so here's what happens when you do this test, and basically you get ice accretion, and you can see, and they'll color the water too. You can see how icing forms, and are the boots adequate? Are they effective? Things like this. But again, controlling this can be extremely difficult, and sometimes you revert to icing shapes. My boss in flight test, I think it was a 402, they put some big foam pieces. They taped them onto the leading edge to simulate ice. I mean, this was several inches, and he was going to go out and fly it. And I don't know why, the details behind these shapes, why they chose these shapes or whatever, but Doug took off, and he came back and said, "We're not doing that." He barely got the aircraft around the pattern. I guess he had such difficulty flying it, had to maintain such a high speed that he said he was fortunate to get the aircraft back on the ground. Well, as I mentioned, they basically moved these aircraft all south. The way to avoid the situation with the difficulty of these aircraft handling the icing was to get them out of it. Of course, it's a little bit less of a challenge when you have a hot wing on the aircraft that can heat the water as it hits the front wing and prevent ice from forming. But of course, the other thing is you want to stay out of the icing. Now, an interesting kind of digression is that when I was involved in the 777 certification, John Cashman, the chief test pilot, mentioned to me that they really didn't need to put wing anti-ice on the 777, and this kind of caught me by surprise. And I'm going, really? That's interesting. And he says, yes, we found out that with the fat wing of the 777, it really wasn't necessary, but the FAA wasn't going to buy off on that, so they installed wing anti-ice on it to be in compliance with the FAA. But he says, that thing can take a lot of ice, and it really is an issue. So I found that very interesting. But anyway, that's the story of the ATR-72 issues with icing. And I'll talk about my flight certification, or my flight evaluation, on the ATR-72. That's the next coming up presentation. I'll talk about that because that ended up being a little bit of political hot potato, and I didn't quite realize it at the time. But I'll talk to you a little bit. It's quite interesting, having the president of ALPA on on board, and I should have actually made a bigger deal of that in my write-up, but I'm not the politician. And the French embassy, the French embassy was quite an interesting event. Let me talk to you about that. But anyway, I hope you found this interesting and informative, and thanks for watching.